Welcome back, day 3 of 2016, squares with the 3 sides. Now that you can think clearly, you move deeper into the labyrinth of hallways and office furniture that makes up this part of Easter Bunny HQ. This must be a graphic design department. The walls are covered in specifications for triangles. Or are they? The design document gives the side lengths of each triangle it describes, but 5, 10, 25? Some of these aren't triangles. You can't help to mark the impossible ones. In a valid triangle, the sum of any 2 sides must be larger than the remaining side. For example, the triangle given above is impossible because 5 plus 10 is not larger than 25. In the input, how many of the listed triangles are possible? Okay, let's get the input into here. We have 2000 triangles. I need to check if they're possible or not. So what do we do? I need to replace these spaces. Processed is processed. Same thing again. Replace space with. Oh, actually, I want to replace 2 spaces with 1 space. So at the end, we only have 1 space. Then I can, because I have so many extra spaces here. Actually, it's just 1 extra space, but sometimes it's 3 spaces, and I just want 1, so I can easily split it. Which I will do now for each line. I want to split the line with space. And then I know first one is the first number. Second one is the second number. And we have a third number, and then we check if each 2 sides is bigger than the third side. So, what are we checking? How many are possible? Okay. What we need all of. Will that work? No. Let's get a list of the 3 options. A plus B greater than C. Or not A plus B. B plus C greater than D. And then we have C plus D greater than B. And then we have D plus B greater than C. And we need all to be true. And then we can map that as our result. And then we have a list of for each line we have 1 result, which is 1 boolean. Which we map. So this is a boolean. And let's have a look. Then we can count the booleans. So we get 3 numbers, custom to int. Check if each combination. Okay, wait, a valid triangle must be larger. Yeah. Ah, yeah. We have 1 space at the beginning, I think, here. So that's the first split. And the other ones are... oh, they're all valid. That's suspicious. For example, this plus this is not bigger than this. Must be something wrong. Maybe I'm gonna have to do this. I was mapping each line to true. So obviously that's true then. Now mapping each line to it. Still wrong. Still got everything. I'm still doing something wrong. Must be something silly. Let's have a look. Print line. B. Let's just do B, C, D, R. Okay, we have false, true, false, true. Interesting. So now I'm just counting elements in the list. And what I want to do is count those that are true. So there's 983. Nice. That was correct. Now that you're helpfully marked up their design documents, it occurs to you that triangles are specified in groups of 3 vertically. Each set of 3 numbers in a column specifies a triangle. Rows are unrelated. For example, given the following specification, numbers with the same hundredths digit would be part of the same triangle. So we have to count like this. How many are possible? It's the same question. We just have to change this process. Let's do part 2 here. So we want to chunk 3 lines. 3 lines. And then we have to do something like parse all 3 lines. Three processed lines. Okay. And then we just have to go. We just have to do the same thing for each line, but map each thing to the correct line. So let's have a look. Or we just collect the triangles. Triangle 1. Just make a list. Var triangle 3. Then we go each line and go in there now and say split the line. Well, it is already split in this case. Okay, to keep it more consistent, I can just keep the split here. So then I just take a line, split it, and then, yeah, one way we can do it is we can add for each indexed. So for each index, give me a thing, and then instead of mapping it into here, I can put it in triangle. Well, I want to put it, if it's 1, I want to put it in triangle 1. When I 1, let's just do it like this. Two. Get this last one. So, yeah, we don't really need vars. We just need mutable lists so we can add them. Then we go for each indexed. Is it correct? Let's see. The first line. No, in the first line, the first element to go in triangle 1. Yeah, it's actually different. It doesn't really matter the index. I just put it in triangle 1, triangle 2. Put A1 in triangle 1, A2 in triangle 2, A3 in triangle 3. Then I look at the next line, put A1 in triangle 1, so I put this one triangle 1, this one triangle 2, this triangle 3. Triangle 1, 2, 3. 1, 2, 3. And then I have a triangle here on the side, and one in the middle, and one on the side. Then I have 3 triangles. So I can just yeah, I can just take them. For each triangle. I can do this. And this is 1 plus 0 greater than triangle 2. 1, 2 greater than 0. Then we have 2, 0 greater than 1. If they're all there, then it's true, otherwise not. Then we, in this case maybe we don't map it, we just for each. Then we have, I mean we can just count as well. So part 2 is 0. Then we just do if our result part 2 plus equals 1. And then we just have result part 2 here. Let's have a look. 1836. Let's see if it's correct. I'm not sure. And it's correct. So we solved day 3. Let's have a look through it again. So part 1, we just needed to count each triangle in the row, and we have to check is this plus this greater than this, is this plus this greater than this, and is this plus this greater than this, and if all is true then we count it. So we just take the row, get 3 numbers out of it, check all the 3 conditions. If all are true, this can be true or false. So if all is, one of them is false, then this is false, and if all are true, this is true. We map it to true, count the truths, and then we have part 1. Part 2, we take 3 lines. So we take 3 lines like this in a chunk. For each 3 lines, we make 3 triangles. The one on the left, the one in the middle, one on the side. For each, and then we have to fill it like this. The triangle 1 always gets the first integer, the 2 gets the second, the 3 gets the third, and then the next row the same. Then we have 3 filled triangles, so we can go and do the same logic to compare the sides. If they're all true, we get true. If one of them is not true, we get false. If we have true, then we can increase our result, which is how many triangles are valid, or possible in this case. Yeah, that's it. Thanks everyone. See you next time.